and welcome to today's C programming tutorial, where we'll be exploring the process of sorting an array of integers. This operation is fundamental in computer science, serving as the foundation for data organization, search algorithms, and much more. We'll dive into the concept without directly looking at the code, focusing instead on the logic and methodology behind sorting an array. Imagine you have a deck of cards, each with a different number. Your task is to arrange these cards in ascending order, from the lowest number to the highest. This is similar to what we're aiming to achieve with our array of integers in C programming. At the core of our method is a special function. Let's call it the sorter. This function takes two critical pieces of information, a pointer to our array. Imagine this as your hand holding the deck of cards, and the size of the array, the total number of cards in your hand. The sorter employs a classic sorting technique, where it looks at each pair of adjacent elements in the array and checks if they're in the correct order, the smaller number before the larger number, just like arranging cards in ascending order. If they're not in the correct order, the sorter swaps their positions, ensuring that the lower number comes before the higher number. This process starts from the beginning of the array and moves towards the end, examining and swapping elements as needed. However, there's a catch. Each time a swap is made, the sorter starts over from the beginning of the array. This is because swapping elements can disrupt the order of previously checked elements. So it's necessary to ensure that the entire array is in order from start to finish. To perform these swaps, the sorter uses a temporary storage space. Let's call it the swap space. Imagine setting a card down on the table temporarily while you rearrange the others in your hand. This swap space holds the value of one element during the swap process, allowing the sorter to exchange the positions of two elements without losing any data. In our practical example, we start with an unsorted array of integers. Imagine this as a shuffled deck of cards with numbers like 12, 15, 66, and so on. Our goal is to sort this array so that the numbers are in ascending order. After the sorter completes its task, our array is transformed. The numbers are now neatly arranged from the smallest to the largest, just like a well-organized deck of cards. This example beautifully illustrates the process of sorting an array in C, showcasing the practical application of loops, conditionals, and array manipulation. Sorting is a critical operation in programming, providing a clear pathway to more efficient data handling and retrieval. Thank you for joining me in this tutorial. Experiment with arrays, sorting algorithms, and see how these fundamental concepts can be applied to solve complex problems. Happy coding, and see you in the next lesson. Welcome to our C programming tutorial, where today we're diving into an exciting and practical example, reversing an array of integers. This concept is not just about flipping numbers. It's a fundamental technique that can be applied in various programming scenarios, from data manipulation to algorithm development. Let's explore this concept without directly looking at the code, focusing instead on the logic and understanding behind it. Imagine you have a series of books on a shelf, arranged in a specific order. One day, you decide you'd like to reverse the order of these books, placing the last book first and the first book last, and so on. How would you go about this in the world of programming, especially in C? This scenario is akin to having an array of integers that we wish to reverse. At the heart of our method is a special function we'll call the reverser. This function takes two important pieces of information, a pointer to our array. Think of this as an arrow pointing to the first book on the shelf, and the size of the array, the total number of books. The reverser works by swapping elements in the array. It starts with the first element, the first book, and the last element, the last book, and swaps their positions. Then, it moves inward, swapping the second element with the second to last element, and continues this process. The swapping continues until the reverser reaches the middle of the array. If you visualize this process, it's like taking the first and last book and swapping their positions, then moving one book inward from each end and swapping again, and so on, until all books are in their new reversed positions. To perform these swaps, the reverser employs a temporary storage location. Let's call it a holding area. Imagine setting a book down on a table while you move the others. This holding area temporarily stores the value of one element during the swap process, ensuring that no data is lost as the elements exchange places. In our practical example, we have an array or a series of books with specific values. Let's say the array contains the numbers 3, 6, 9, 10, and 11. We want to reverse this array so that the last number comes first and the first number goes last, and so on. After the reverser has completed its task, our array is transformed. The numbers are now in reverse order, showcasing the power and utility of this function. This process not only changes the order of the elements in the array, but also provides a clear demonstration of manipulating data structures using pointers and loops in C. So there you have a practical demonstration of reversing an array in C, all without directly looking at the code. This technique is a valuable tool in your programming arsenal, useful in sorting algorithms, data processing, and many other areas. Thank you for joining me on this programming journey. Experiment with arrays, pointers, and functions, and see how you can apply these concepts to solve various problems. Happy coding, and I'll see you in the next tutorial. Welcome to our C programming tutorial, where today we'll be exploring how to determine the length of a string without peeking directly at the code. Instead, we'll dive into the conceptual understanding and the logic behind this seemingly simple yet fundamental operation in C programming. So let's embark on this journey together and uncover the secrets of working with strings. Imagine you're on a treasure hunt where each step you take is marked by a stone on a path. Your goal is to find out how long the path is by counting each stone until you reach the end. In the world of programming, especially in C, this path is akin to a string, and the stones are the characters that make up the string. At the core of our adventure today is a special function we'll call the length finder. This function embarks on a journey through the string, one character at a time, counting each step it takes. The journey begins at the first character of the string and continues until it encounters a special marker, known as the null terminator, which signifies the end of the string. This null terminator is like a sign that says, the path ends here. The length finder is meticulous and patient. With each character it encounters, it takes a step forward, marking another tally on its count. This count is crucial, as it represents the total number of steps, or characters, along our path. The function doesn't rush. It savors each step, ensuring no stone is left uncounted until it reaches the end of the path. Once the length finder reaches the end, it has a complete tally of the steps taken, which corresponds to the length of our string. This length is then shared with us, revealing the total number of characters in the string. It's like the function is saying, I've explored the path, and here's how long it is. In our practical example, we use the length finder to measure the length of a specific string. Let's say string. We're curious to know how many characters make up this word. So we set off on our journey with the length finder, counting each character until we reach the end. And voila, the function returns the total length of the string, providing us with the answer we've been seeking. This process not only teaches us about the mechanics of strings in C, but also illustrates the importance of understanding how data is structured and manipulated in programming. Knowing the length of a string is foundational for many operations, from processing text to managing data efficiently. So there you have a conceptual exploration of determining the length of a string in C, without even looking at the code. This understanding forms the basis for more advanced programming concepts and challenges. Thank you for joining me on this learning adventure. Remember, practice is key to mastering these concepts. So I encourage you to experiment with strings, functions, and pointers on your own. Happy coding, and I look forward to our next tutorial. Hello, fellow coders! Today's C programming tutorial will guide you through a fascinating journey of working with strings and how to display them using custom functions. We're focusing on a particular program that prints a string to the terminal without directly peeking at the code. Instead, we'll unwrap the concepts and mechanics behind it, ensuring a deep understanding of how things work under the hood. Imagine you have a box of pearls, where each pearl represents a character in a string. Our goal is to display this string of pearls one by one. But here's the catch. We're going to do it by first counting how many pearls we have, then going back to the start, and finally, showcasing them all together. Sounds intriguing, right? Let's dive into how this is achieved. At the heart of our program is a special function. Let's call it display string. This function takes a sequence of characters, akin to our string of pearls, and prepares to show it to the world. The first step in our function is to understand the length of this string. We do this by initiating a journey from the first pearl to the last, counting each pearl as we go along. This is similar to walking along a path and counting your steps until you reach the end. Once we've reached the end, we know exactly how many pearls or characters our string contains. However, there's a twist. Having reached the end, we now need to return to where we started because we want to display the entire string from the beginning. This step is akin to retracing your steps back to the start line after a walk. We carefully move back, ensuring we're ready to showcase our string in its entirety. Finally, the moment of truth arrives. We use a special command, known as write, to display our string of pearls. This command takes 3 parameters: where to display the string, in our case, the terminal, the starting point of our string, and the number of characters to display. With a flourish, our string is revealed, character by character, on the screen. This simple yet elegant process not only displays a string, but also teaches us several fundamental concepts in C programming. We learn about string manipulation, the importance of understanding string length, and how to navigate through strings using pointers. Moreover, we delve into the use of system calls, like write, to perform basic input-output operations, a critical skill in systems programming. So, there you have it, a deep dive into displaying strings in C without even looking at the code. By understanding these underlying principles, you're better equipped to manipulate and display data in your C programs. Thank you for joining me on this programming adventure. Practice these concepts, experiment with strings and pointers, and continue to expand your programming toolkit. Happy coding, and I'll see you in the next tutorial. Welcome to our C programming tutorial, where today, we'll explore the concept of performing division and modulus operations on variables, and then updating those variables directly with the results. This example offers a deeper dive into the utility of pointers in C programming, enabling us to manipulate data directly within memory. Let's embark on this journey, understanding the process without delving into the code itself. Imagine you're on a treasure hunt, where the treasure map gives you a number of steps to walk, let's say 21 steps, and then instructs you to divide these steps by a certain number, in this case, 8 steps to find the X marks the spot. But there's a twist. Not only do you need to know how many full sets of 8 steps you can take the division, but also how many steps you'll have left over the modulus to take a final, smaller step to reach the treasure. In our program, we've crafted a special function named the ultimate divider and modulator. This function takes 2 pointers as parameters, each pointing to an integer. Think of these pointers as arrows, where one points to our total steps 21 and the other to our step divisor 8. The ultimate divider and modulator performs a critical 2-step operation. First, it calculates how many times 8 steps fit into 21 steps, which tells us how many full sets of steps we can take. This quotient is temporarily stored in a safe place. Let's call it resulta. Then, it calculates how many steps we have left after taking as many full sets of 8 steps as possible, storing this remainder in another safe place, result. Here's where the magic happens. Instead of just telling us the results. The ultimate divider and modulator goes back and changes the original numbers. It updates our total steps to the number of full sets of steps we can take, the quotient, and our step divisor to the number of leftover steps, the modulus. It's as if the treasure map itself changes to show us how close we are to the treasure after each calculation. By the end of this operation, our variables a and b have been transformed. A now represents the number of full sets of steps we can take, and b shows how many steps are left for that final stride to the treasure. This example beautifully illustrates the power of pointers in C programming. By using pointers, we're not just passing values around. We're directly manipulating the data in memory, allowing for dynamic updates and calculations. So there you have it, a practical demonstration of division and modulus operations in C, showcasing how to update variables directly using pointers. This concept is crucial for efficient memory management and data manipulation, laying the groundwork for more advanced programming techniques. Thank you for tuning into this tutorial. Experiment with pointers and functions, and see how they can make your code more efficient and powerful. Happy coding, and I look forward to our next adventure in programming. Welcome, coding enthusiasts, to our C programming tutorial channel. Today, we're diving into a fascinating aspect of programming: how to divide to numbers and find the remainder, also known as modulus, using pointers. Our example will not only teach you about arithmetic operations in C, but also show you the power and utility of pointers in passing and modifying data within functions. So let's get started without directly looking at the code. Imagine you're at a market and you have 8 apples. You want to divide these apples evenly among 2 friends. How many apples does each friend get, and are there any left over? This scenario is exactly what our program tackles, but in the world of C programming. At the heart of our program is a special function. Let's call it the divider and modulator. This function takes 4 parameters. The first 2 are the numbers you want to divide and find the modulus of, in our case, the 8 apples and the 2 friends. The other 2 parameters are pointers, which might sound intimidating, but think of them as arrows pointing to specific locations where we want to store our results. The divider and modulator performs 2 key operations. First, it divides the number of apples by the number of friends to determine how many apples each friend gets. This result is then stored in the location pointed to by the first pointer, which we'll refer to as our division result. Next, it calculates the remainder of this division, answering the question: are there any apples left over after dividing them equally? This remainder is stored in the location pointed to by the second pointer, our modulus result. To see this magic in action, we set up our scenario with 8 apples and 2 friends. We then call the divider and modulator function, passing the number of apples, the number of friends, and the locations where we want our division and modulus results to be stored. After the function works its magic, we check the results. The division result tells us how many apples each friend gets, and the modulus result tells us if there were any apples left over. In our scenario, each friend gets 4 apples, and there are no apples left over, exactly what we expected. This simple yet effective example shows how pointers can be used to pass data to functions and modify it. By using pointers, we're able to store our results directly in the variables we're interested in, making our code efficient and our programming more powerful. So there you have a practical demonstration of division and modulus operations in C, leveraging the power of pointers. This concept is fundamental in understanding how data is manipulated and passed in programming, laying the groundwork for more complex operations and algorithms. Thank you for watching this tutorial. Experiment with these concepts, and don't hesitate to get creative with pointers and functions. Happy coding, and see you in the next tutorial. Hello, everyone. Welcome to another episode of our C programming tutorial series. Today, we're going to delve into a simple yet fundamental concept in C programming: swapping the values of two variables using pointers. This concept is not just about changing numbers. It's about understanding how to manipulate data at its most basic level in memory. Let's begin with the essence of our program, which revolves around a special function we've designed for this purpose. Let's call it the swap function. This function is the magician of our show, performing the classic trick of swapping to values. But instead of sleight of hand, it uses pointers. Now imagine you have two cups in front of you, each containing a different colored liquid. One cup holds a blue liquid, representing our first variable. Let's name it A. And the other holds a red liquid, representing our second variable, named B. Initially, A is filled with the number 41, and B with the number 42. Our goal is to swap these contents without directly pouring them into each other. Sounds magical, right? That's what pointers allow us to do in C programming. The swap function takes in the addresses of A and B as its inputs. Think of these addresses as the exact locations of our cups in a vast room. By knowing their locations, our function can directly manipulate their contents. Inside this function, we introduce a third cup. Let's call it C, which will temporarily hold the value of one of our variables. Here's the trick. We first pour the liquid from B into C, emptying B. Then, we pour the liquid from A into B, and finally, we pour the liquid from C into A. And voila, the contents of A and B are swapped. After performing this magical swap in our program, A now contains the value 42, and B contains the value 41. The beauty of this process lies in the fact that we've managed to exchange their values without directly transferring the contents from one to the other. Instead, we use their addresses to manipulate them indirectly. This simple example sheds light on the power of pointers in C programming. Pointers provide us with a direct line to manipulate data at its core, offering a level of control that's both powerful and elegant. So, there you have it, a practical demonstration of swapping values using pointers in C. This fundamental concept is a stepping stone to more complex data manipulations and a critical tool in your programming arsenal. Thank you for tuning into this tutorial. Remember, practice is key to mastering these concepts. So I encourage you to experiment with pointers and functions on your own. Happy coding, and I look forward to seeing you in the next tutorial. Welcome back to our C programming journey. Today, we're going to unravel a complex but fascinating topic: multi-level pointers, and how they can be used to manipulate data through several layers of indirection. Our example program demonstrates this concept in a way that's both intriguing and educational. Let's dive in without directly looking at the code, but rather understanding the concept it embodies. Imagine you're standing in front of a series of mirrors, each reflecting the image of the other. In C programming, we can have a similar setup with pointers, where one pointer points to another, creating a chain of references all the way down to a value. This concept is what our program explores using a multi-level pointer structure. At the core of our program is a special function. Let's call it the ultimate function. This function takes a very special parameter, a pointer that has been pointed to by another pointer, and so on, 9 levels deep. Yes, you heard that right, 9 levels of pointers. The purpose of this function is simple yet profound: to set the value at the very end of this chain of pointers to 42. Why 42? It's our chosen value to demonstrate this concept, symbolizing the answer to everything for those familiar with a certain science fiction humor. But how do we create such a chain of pointers? That's where another function comes into play, which we'll refer to as the pointer function. This function sets up this intricate structure. It starts with a pointer pointing to an integer, then a pointer pointing to that pointer, and so on, building up to 9 levels. Then, it calls the ultimate function to set the final value to 42 through all these layers. Finally, in the main part of our journey, we start with a simple integer and progressively build our multi-level pointer structure. culminating in calling the pointer function. This entire setup serves one purpose: to change the initial integer's value to 42, showcasing the power of pointers in C. After this grand setup, we check our initial integer's value. If everything went according to plan, it should now proudly display 42. A testament to the successful navigation through our multi-level pointer maze. This example demonstrates not just the technical capability of C with pointers, but also the conceptual beauty of programming. It's like conducting an orchestra, where each musician pointer plays a part in achieving the symphony's climax, changing the value to 42. In closing, this tutorial peeled back the layers of multi-level pointers, showing how they can be orchestrated to achieve a specific outcome. It's a powerful demonstration of indirect manipulation and a concept that's crucial for understanding more complex data structures in C. Thank you for joining me on this deep dive into pointers. Remember, the complexity of pointers is not something to shy away from, but rather an opportunity to explore the depth and power of C programming. Happy coding, and until next time, keep unraveling the mysteries of programming. Hello, and welcome to our C programming tutorial. Today, we're diving into the world of pointers and functions. Specifically, how to change the value of a variable using a pointer within a function. Let's break down a simple program that illustrates this concept beautifully, step by step. First, we start with including the standard input-output header file, STO-H, which allows us to use the print function. This is a staple in almost all C programs for input and output operations. Now, let's talk about the heart of our program, a special function named ft_ft. This function takes one parameter, a pointer, to an integer. The purpose of this function is straightforward but powerful. It sets the value pointed to by the pointer to 42. Why 42, you might ask? Well, it's just a reference value for this example, but it demonstrates how you can directly manipulate data in memory through pointers. Moving on to the main function, which is the entry point of any C program. Here, we declare a pointer to an integer. It's crucial to understand that a pointer stores the memory address of a variable rather than a direct value. Our goal is to change the value at this memory address. Here's where the magic happens. We directly assign the value 42 to the location pointed to by our pointer. This line showcases the power of pointers, allowing us to modify data in memory directly, a fundamental concept in C programming. After changing the value, we want to make sure our operation succeeded. So, we use the print function to print the value pointed to by our pointer, which should now be 42. This is a simple way to verify that our function worked as intended, changing the value in memory to what we wanted. Finally, our program gracefully exits by returning 0 from the main function, signaling that everything went according to plan. In summary, this program is a concise but effective demonstration of using pointers and functions in C2. Manipulate data in memory. Understanding pointers is crucial for working with arrays, strings, and more complex data structures in C. They allow us to work directly with memory, giving us powerful control over how our program operates. That's all for this tutorial. Remember, practice is key to mastering these concepts. So don't hesitate to experiment with pointers and functions on your own. Thank you for watching, and happy coding!